Today we're going over the study guide for lessons 6.1 to 6.4 for your quiz on Monday. The first two here, as you can see, are graphing, and you need to graph them to be able to tell whether they have one solution, infinitely many solutions, or no solution. You can also look at their slopes and their y-intercepts, and if they have different slopes, we know that they should have one solution. If they have the same slope but different y-intercepts, we know they should have no solution. And if they have the same slope and the same y-intercepts, we know they should have infinitely many solutions. So, even before you graph here, you can look, since they're in slope-intercept form already, for number 1, it has y equals 1/2 x and y equals x plus 2. Since they have different slopes, you know already that they should cross or intersect and have one solution, and we're going to name the solution as an ordered pair. So we need to make sure they're in slope-intercept form, which they are, and then we draw our graph. For the first one, since there's no y-intercept or no b value there, that means you start at 0. So we're going to put a point at 0. Then we use the slope, 1/2, to continue, so that goes up 1 to the right 2. Or down 1 from the original point to the left 2. So that would be my first line. And then my second line is going to start at 2, since that's the y-intercept. The slope is 1, so that's up 1 to the right 1, or down 1 to the left 1. And draw my line. And it looks like they intersect at 1, 2, 3, -4, -2. So that would be my ordered pair or my solution, and this has one solution. Now the second two equations are not in slope-intercept form, so they need to be put into slope-intercept form before we start. So I'm going to erase the first problem, and we'll look at the second problem. Before we can determine anything, even graphing or how many solutions they have, we're going to put them in slope-intercept form. So that's what we'll do first. I need to move the x value over to do that, and then I have to divide everything by 3. To get my answer. So this is what I'm going to graph. Y equals -2/3 x plus 10/3. And now we'll put the other one in slope-intercept form. So we're going to take 4x plus 6y equals 12 and put this into slope-intercept form. So we move the x value over and divide everything by 6. And I get y equals -2/3 x plus 2. So if I look at both of these now, I notice that they have the same slope, but a different y-intercept. So this is actually going to be no solution, so they're not going to cross. But we do need to graph them both still, so we're going to graph them. It also means they're going to look like parallel lines. because they have the same slope. So for the first one, we're going to start at 10/3, which is the same as 3 1/3. This is about here. And we go down 2 to the right 3. And draw my line. And the second equation, we're going to start at 2 and also go down to the right 3. And as you can see, these are not going to cross. They're going to be parallel lines. So this would be no solution. For the next two, we need to solve the system using using substitution. So we're either going to have, again, one solution, no solution, or infinitely many solutions. So the first thing we need to do for substitution is we need to make sure that the first equation or the second equation, either one, is equal to y or x. So I would say the second equation for number 3 would be easier to change so that it's equal to y, because all we would need to do is divide everything by -3. So here's the first equation. And the second equation is -3y equals -6x plus 18. So I chose to make the second equation equal to y. And we're going to take that y equals, and we're going to substitute it now into the y value for the other equation. And we do that by taking 2x minus 6 and plugging it into the y value there. Now we're going to solve for x when we do that. So we have a minus sign here, so that's going to apply to both the 2x and the -6. So we have 2x minus 2x plus 6 equals 6. And notice that the variables cancel themselves out. When that happens, you're either going to have no solution or infinitely many solutions. So since they canceled out, we look at the statement, and since 6 does equal 6, this is actually going to be infinitely many solutions. Now, if you canceled out the variables and you got something that did not equal the same number, then it would be no solution. And if the variables don't cancel out, like the next example, you're going to have one solution where you have an x value and a y value. Here we're also solving using substitution, so we need to make either equation equal to y or x. I choose the first one since all we have to do is move the 2x over, so it becomes y equals -2x plus 3. And now we take the -2x plus 3 and plug it in for y into the other equation to be able to solve for x. We have to distribute the 4. Continue to combine like terms. And then get x by itself. So x would be equal to 1. Once we find x, we plug it back into either equation. Let's say we plug it into the first one. and we get what y is. So negative 2 plus 3, which is also 1. So my answer would be 1, 1. Next, we're looking at the table here, and we need to write an equation for each region's tourism rate. So the regions could represent y, so we would have y equals 40.3 plus, and you have a rate there, so that's going to be your slope, so plus 0.8x, and that would be our first equation. You might want to put the 0.8x first, just because that's what slope-intercept form usually has. And then the second equation, which would be the Middle East, could also be equal to y. The rate is 1.8, which is our slope, and then plus 17 million for what they already have. So those would be our two equations. Now if we were to answer letter B, which says if the trends continue, in how many years would you expect the number of tourists in the regions to be equal? You'd have to solve for x, because x represents the number of years in our equation. So we're going to use substitution. So we have y equals 0.8x plus 40.3, and we have y equals 1.8x plus 17. So it doesn't matter which one you take, since they're both equal to y, and you take the first equation and substitute it in for y into the second equation, if that's what you want to do, or vice versa. But what's going to end up happening is you're going to end up having the equations equal each other, and then you're going to solve for x. So x would be equal to 23.3. So what that means, if we go back to the problem, it would mean that in 23.3 years, the number of tourists in the regions would be equal. For the next 4 problems, we're going to use elimination to solve. So we have negative v plus w equals 7. And v plus w equals 1. And with elimination, you need to line up the variables so that you have like terms on top of each other, and then you're looking for either opposites or the same term. Remember that opposites, to eliminate one of the variables, you need to add everything, and if they have the same sign, you would need to subtract. So in this case, we actually have both options available if we want to choose. Let's say we want to cancel out the v values. That means we would need to add, because we have a negative v plus a v, and that would make it cancel itself out, which is our goal. So we're going to add everything else. So w plus w is 2w, 7 plus 1 is 8. And then we solve for w. And then with w, we can plug it back into either equation and solve for v. So let's do the second equation. So v would be negative 3. So my answer would be 4, negative 3, or negative 3, 4. Since they're not x and y values, you don't have to write them as an ordered pair. Here's the next problem where we're going to use elimination to solve. So in this case, the a values are both the same sign, so we're going to subtract to eliminate them. Then we do subtraction, 4b minus 10b, which is negative 6, and negative 4 minus negative 16, which is going to be positive 12. And then we divide by negative 6. oops, to get b is -2. And again, like the last problem, we plug it into either equation to solve for a. So I'll just pick the first one. So we would get a equals +4. And we can write it as 4, -2 or -2, 4, again, because we don't have an x and y variable, so we don't have to write it as an ordered pair. Here's our next problem that we need to use elimination, and in this case you can see the 3's are the same, but they're opposites, so we would need to add to cancel them out. And we add everything else, so -8 plus -5 is -13y, and -24 plus 4.5 would be -19.5. And then we're dividing by -13, which gives me +1.5. And I'm going to take that one and plug it into y for either of the equations. Let's take the second one. And solve for x. So 5 times 1.5 is 7.5. So I need to get x by itself. Combine like terms. So x would be 4. Since we have the x and y values, we're going to write this as an ordered pair. 4, 1.5, or x comma y. And here's our last problem. We're solving using elimination. So we need to subtract, because we have the same sign in this case. And that would be eliminating our y values. So 4 minus 3 is 1. Or x. 6 minus 7 is -1. So x would be -1. And then we're going to plug -1 back in to x to solve for y. So let's choose the second one. It doesn't matter. And so we're going to add 3. We get 3y equals 10. So y would be 10/3. And you can keep that as a fraction. So our ordered pair would be -1, 10/3. And our last problem is a multiple choice problem. So it tells us to find the value of c. So we're going to solve the system. You have 6c minus 9d equals 111. And 5c minus 9d equals 103. So we're going to need to solve for c. So you can cancel out the d values here. It's the same sign, so we're going to same sign, subtract. So that cancels out the 9d's, and we are left with 6c minus 5c, which is 1c, or just c. And then 111 minus 103, which is 8. Now, since it only asked us to solve for c, we only need to look for 8 as our answer. And that would be letter C. And that concludes our study guide review session.